In this video, I break down the solution for challenge number 8, Volt of Ethernaut CTF. This is part of a series of videos breaking down the solutions for every challenge in this CTF. So stay tuned for more. And I explain the reasoning behind the solution so that anyone can understand what's going on and do it themselves and learn from it. So, hello and welcome to the DecentraWise channel. My name is Pedro, and here we share all things Web3, blockchain, development, and security. So, if you like this nerdy stuff, you are in the right place. Let's go on. So, first of all, we need to add to our Ethernaut website, and we need to connect our MetaMask and all that. So, if you don't know how to do that and need some guidance, add to the first video in this series where we explain all those things. We also need to open the console in the browser, and we will have something like this. So that we can interact with the contracts and the challenges in this CTF. So we are going to click our challenge number 8, Volt, and let's see what we have here. So we have a Volt, so it seems, right? And we need to unlock it. So we need a drill, and we need to make a hole in the vault. No, it's not like that. So let's see the code. So we have a password which is private, and it's set in the constructor. So probably we cannot know this password because it's private, right? Wrong. No. There is one thing in blockchain, which is transparency, and everything in blockchain is public. So if it's not encrypted, anyone can know it, right? Although we don't have an easy way to get directly the password from the contract, because by having a private member in the contract, the Solidity language will not create automatic getters. So there is no password function so that we can get the value out of the password member, but it's stored somewhere, right? It's stored in a slot, in a data slot in the storage of our contract. So we can and we will get it from the storage, right? So how can we do that? So we don't even need to create any contract for this. We just need to interact with the chain. So first of all, let's see what is the ABI of our contract. Await contract dot. So we have locked. We have a locked function. We need to get an instance first. Sorry, let's get our instance to play with. There we go. Now we have an instance, and there it is. So now we can get the value of locked, and it's locked. Our vault is locked. So that is the initial state, and we probably have a password, but we don't have a function that gives us that. There is no function that we can call. So what we can do to get this is to access directly the storage. So how do we do it? So await, and we will use Web3.js, Web3, and let's get storage at. It's the function. Sorry, it's not here. It's on eth.get storage at. Now we have it. And what we need to pass to this function? We need to pass an instance, so it's our instance, and what storage slot we need. So in storage slot 0, we will have the value 1, which is probably the locked, right? It's true. And on slot 1, it's a bytes 32, so it will occupy the entire slot. It will be the password, hopefully. So let's check the slot 1. And we have an hexadecimal thing. So now what? So we know that this is bytes 32. So bytes 32 is a string packed in an hexadecimal field. So how can we get the string out of it? Okay, we can inspect it by transforming it to text, back to text. So we don't need it because we can pass this directly to our unlock, but just out of curiosity. So let's get our text out of the text of the password, right? So let's do it. We can do Web3 once again, utils, and we have a function here which is hex to ASCII. Ta-da! There we go, hex to ASCII, and we pass the storage that we want to get, which is the other line before. So storage 1, and let's see. Haha! It's a very strong password, right? A very strong secret password in the smiley. So this is our password, okay? So how can we do the unlocking of our contract? So we can just call the unlock function with this get storage line, and we will be good to go. So let's do it. Await contract dot unlock. There it is, unlock. And now we will pass the await get storage at blah blah blah, the storage number 1, right? Let's check. MetaMask, approve transaction, and boom, we have our transaction receipt, so we can check if the contract is still locked. Let's see. False. Okay, so probably if we go get the storage at position 0, it is 0. So this is it. I think we have passed this challenge. Let's submit our instance, approve, and there we go. We passed the challenge. So this is it. I hope you understood that everything in blockchain is public. So we can, even if the function is private or the data member is private, we can get it from the storage directly without any problem. So the hardest thing that we can encounter in this kind of situations is just the unpacking of the fields, because Solidity and DVM packs several fields in one storage slot, usually to save space. So this is just a very easy thing to break, right? So just unpacking and getting the values out of 256 slot is very, very easy. So I hope you understood that we shouldn't store stuff that is private on blockchain, and hope you don't do vaults like this, right? So hope you liked this video, and if you got value from it, just smash that like button and subscribe, because we are sharing videos like this all the time. And let's have fun with vaults with passwords, because they are funny. And thanks for watching. See you in the next video. Bye bye.